Kimmo Lylykangas, kes mitte ei ole ainult arvutanud, vaid on ka ehitanud ja mõõtnud, mis mulle imponeerib väga, et see ei ole mitte mingi juhuslik teadmine. Algusest lõpuni. And we turn now into English language.
I will continue on the same topic in English language, but I would like to put my presentation in another context with presentations. I had planned this beforehand because I didn't know exactly what the other presentations will be about, so I planned that I will tailor my introduction while listening to other presentations. The three observations are, firstly, if you look at the most recent prognoses on global warming, you can see that the big turn towards reduction of emissions hasn't taken place. And even if we would do it today, we would still not reach the Paris Agreement target, plus 1.5 degrees global warming. So we know now, although we are not discussing it publicly, that the good options are gone. We are looking at future scenarios that are less pleasant, and our children and grandchildren have to face the consequences. Second observation is equally disturbing. It is that climate action has become political, entirely political. And this means that even if this government that we have now in Finland or Estonia would do very ambitious climate work, next government can basically undo, cancel everything. And this is what we saw already happening in the United States 9 years ago when the United States Senate was having an election, whether the climate change is a hoax or not, and whether it is man-made or not. Do you know how they left it? They decided that climate change is not a hoax, but they were very unsure if it's man-made. And this is like Catholic Church deciding about Earth being flat or not. This is, of course, a question of science, not a question of politics. And as a consequence, in the United States, for example, whenever there's a Republican president, they will take off the photovoltaic panels of the White House roof, and the Democratic president will bring them back again. And this is very, very harmful for climate action. The third observation is that if in this moment of time you want to make a meaningful career in architecture, you cannot ignore the climate change. And this is the context for my presentation. The same graph that you saw here, this is not the long arm of Brussels reaching out towards Estonia and making your work miserable and more difficult. This is the tool that you want to have to understand how you can improve your performance as architects. Yes, it is a calculation tool because we are dealing with quantitative problem. We are causing too much emissions. We want to know where they come from and how much is too much. But if the result is 297, this is not yet very informative. Okay, now I should improve. Is this good or bad? What did I do wrong to get this result? How should I improve? Like all these tools, this is not perfect for all the things. And in order to understand what it tells us and what it doesn't tell, we need to know what we are actually calculating and what we cannot apply it for. And just to know that this is where the result comes from, in our case, is already rather informative. We can also look into this calculation and try to understand what we are actually quantifying, what causes these numbers, and when we sum them up, we get this result. Can we change something? And this is the question, same graph here, and I'm trying to open it up a bit. You've seen probably all these names that we use to describe different kinds of emissions, right at the gate, describing the industrial emissions of material production and so on. We can see here that the novelty here is that we are talking about materials. Estonia has had for a long time strict regulation on energy efficiency, more strict than Finnish regulation actually. But now we are talking about materials, and actually this diagram here reveals what happens with the materials. It's like hysteric logistics, transporting all the time our materials here and there. Transportation is everywhere. We transport waste, we transport raw materials, we transport them to factory and to building site. So-called embodied emissions is not just a package about materials, but it consists of energy used, diesel burned to transport the goods and so on. And to get our hands into this calculation, we need to know simply what's the weight of our building. That's not too much to ask. It would be nice to know if we design a building, what's the weight of this building. And if you get that number, and if you have the energy number, it will be doing fine. Because around this box here, all the rest of the categories evolve, describing the flow of materials from raw material extraction until the demolition of the building. So, what can it say and what can it tell to us? This is often asked in education and by our students and in training sessions. To some extent, carbon footprint of a building can tell us about site conditions. As we heard from Alvin's presentation, if the soil needs high foundation, if it needs stabilization, this is a difficult place to build, you will get a high carbon footprint. It can reflect the use of local materials and low-tech materials, if you like. This is not excluded. We have two layers here. We have the LCA method that is described by the graph, and then we have the layer of regulatory default values. With the good aim, the regulatory layer aims at having comparable results, but sometimes it also simplifies things and leaves certain things out. For example, the Finnish discussion was a lot about what to do with underground spaces. We know that they are concrete, there might be a lot of construction underground. But if we take them in, two buildings are very difficult to compare, because the other one might have a lot of stories underground and another one doesn't. This is a regulatory layer. We want to compare, so we have to exclude something to be able to compare. But if you just want to know, you of course include everything for the sake of knowing, and then you can improve your processes and way of working. Reuse of materials can be included, but what cannot be included, for example, in the Syky competition in Tartu, we were asked, what if we fell all these trees? What is the climate impact? It's not actually directly included in this method. That's another story, methodology that is still evolving, developing, will be soon available, but can also apply this kind of LCA principle. And the recent studies actually show us that a single tree in a city can be either carbon sequestration, taking CO2 out of the atmosphere, or releasing it. So it's not automatically so that any plant, any vegetation is just a positive in the city. What it cannot tell us is the impact of location. Oftentimes I'm asked, what if I place it in a suburban area or in the city center? Can you calculate the carbon footprint and tell me which one is better? No, there's a module for that in the framework, but we are not using it. The city is much more complex system than this, and it's actually would take a lot of simplification to say that placing your house in suburbia would be so much worse than placing it in the city center. For this we have different methodologies. There's a Norwegian methodology actually that takes it into consideration, but we don't. That's another story. And then if you are a wise resident of your house, if you use it well, if you save energy, if you keep good care of your house, this doesn't show, because this is based on standard use. We assume the same kind of use for all the buildings, so it's kind of eliminated to be able to compare. If you want to take it into account, you can, but then you are not following the method that is kind of meant for the regulatory purposes. And then long service life of the building. I will get back to this question later. The methodological framework for greenhouse gas assessment is actually very complicated. In the upper row here, we can see the national greenhouse gas inventories, and the IPCC guidelines have pretty much harmonized this process. Maybe you know that quite recently the new greenhouse gas inventory for Estonia was completed 2 weeks ago. I'm not sure if it was published yet, but this is an annual inventory that is considered the most important, globally the most important monitoring system for our success in climate action. So if we do something with the buildings, but it doesn't show it in national inventories, then does it really pay off? We should do things that are reflected in the national inventories. Then we have the layer of subnational accounting. This means cities and regions. And this is totally unharmonized. It's a jungle. There are different methodologies applied. City of Tallinn is now doing a greenhouse gas inventory for 2021. And they want to align it with the national inventory so that it's kind of comparable with the national inventory methods. But what is missing is so-called scope 3. And all the material emissions that we are talking about today belong to scope 3. So City of Tallinn's greenhouse gas emission inventory doesn't say anything about materials. And I know that the city officials in the City of Tallinn were asked to quantify the climate impact of the new tramline. How would they do it if the materials are missing? Or the whole renovation, if you assess the impact of renovation, you get only positive results. Because for renovation you need to invest some materials, you need less energy afterwards. But now the materials are missing, so our understanding of the Tallinn emissions is actually very limited. And this is simply because this is globally just developing, the methods are developing and there is no consensus how to estimate the emissions for cities. There are two pathways that we are looking into in our research team, consumption-based and territorial. And now the building method is actually more leaning towards consumption-based method. And this causes some methodological difficulties that I don't have time to discuss right now. But the difference between the methods is that the carbon footprint of a building sees the process of the building from raw material extraction until the end of life as a linear process of time, whereas the city inventories are looking at 1 year, what just happened, and try to quantify that. That's why they are not directly comparable. And a slice of the building's life is included in the city inventories and national inventories like this, usually just the energy. And now the question, why are we using 50 years as a lifespan in this building carbon footprint calculation? Isn't that too little? I'm often asked, buildings should last much longer. Look at the buildings in the old town. Why are you saying that it has to be 50 years? Well, the building won't collapse after 50 years because of our calculation method. This is the regulatory layer, because we want to compare. And the point of view for this calculation is the moment when we know something about the materials, but we don't know how long this building will last. Maybe there will be a new master plan that says that this has to be demolished after 5 years. We don't know. It's speculative. Future is speculative, but to be able to compare and set some limit values, we just assume that, let's say, 50 years. Why not more? It would be nice to have buildings that last for 500 years. Because then the results would be entirely dominated by the energy use. And the materials would be just a tiny slice in the result that would make no difference at all. So with the 50 years lifespan, we have rather good balance between the materials and energy use. Specifically in Estonia, this is dominated by energy use. If you go to Sweden, the results are totally different. Iceland, Norway, the energy is very small, mainly because the grid electricity is so low carbon there. And 50 years, by the way, in Finland, if you look at the average age of a demolished building in Finland, that's about 47 years, so it's not that far-fetched as an average level. So it's for comparability. The longer service life would give us different kind of results. It is still only a good thing if you want to make long-lasting buildings. And if you think about buildings in Old Town, for example, that's an interesting perspective. If they have been there for 400 years, then the carbon footprint assessment actually comes very close to the carbon footprint assessment of infrastructure. When we decide to build a new road on Arthur Street, for example, the idea is that it's there for good. The idea is not that we take it away after 50 years. The infrastructural investment is there for good. And the time perspective is something that is really difficult to estimate and include in these assessments. And maybe the Old Town assessments would be something similar, where the main focus is actually on the maintenance, energy performance, the annual use, instead of this kind of a bit shorter service life. And we could use the same method also to assess the buildings that are being demolished. We could look at it from this perspective here. And now the courthouse building will be demolished. We could look behind and see how many years did it serve, Can we learn something from this? Can we make a better building that will serve a longer time? Is it a design question why it's demolished, or building physics, or city planning? Maybe this could be also an interesting perspective. Now it is just that we are using this method from the previous point of view, from here instead of here. And here the difficulties would be different. We would understand the real service life of the building, but there would be a lot of uncertainty to understand how the materials were originally made. Long time ago, they were local materials and man-made materials where the emissions actually would be really, really low, and they weren't transported for natural reasons for a very long time. Comparisons would be very difficult, but not in the way that regulation wants to be. Then the reuse of materials. Reused materials come in without emissions, and there's a benefit. This is one example that we calculated for a central project with Kadrian. This building had the test hall, foundation, and underground floor that was kept. We estimated that 7 to 8% using the old emission factors were saved because we were able to, or the light was able to use the old structures. I think that our professional activity will be more and more characterized by this kind of work. For example, in Aalto University, the main design studio for the second year students was changed a couple of years ago. Now it's an adaptive reuse studio. It used to be building technology studio. And that reflects the change in our work. We are more and more reprogramming buildings, reusing the materials, trying to increase the material of the material that was already once considered waste and worthless. What else can we do with low carbon architecture than show good results in carbon footprint? If I tell you that this is just one tool and it cannot do everything, what are the other tools that we have in architecture? The impacts on city scale you won't show, but they are many. The economic use of building, we can encourage it, we can make it easier. We can invest in adaptability that Alvin was referring to. Because over a long period of time, if the building is really strictly designed for one purpose, and these keep on changing, that means more renovations, more material investments. In the worst case, it means that the building will be demolished. So if you look at the future architecture, maybe the buildings look less like specific buildings for one use. They become more generic in a way. They can still have strong identity and character in architecture, but they are not that much bound to one use, but they are rather flexible in their use, from offices to apartments and back, and they serve a longer time. Low carbon lifestyle is something that doesn't show in carbon footprint metrics, but it's something we as architects can encourage to. If you think about urban farming, there's no way you can make it visible in carbon footprint, but that doesn't mean that it's a bad thing or you should ignore it. And one important thing that doesn't come to show in carbon footprint is how many square meters we have per one person. You imagine this very rich person here on the right side building himself a Dutch of 1,000 square meters and living that happily. And then we have a 1,000 square meter townhouse that houses 20 families. If the unit is CO2 kilograms per square meter, we cannot see the difference. But of course, this makes all the difference globally. So if the global population is exploding and at the same time the square meters per one resident is also increasing, we have a double impact on global warming happening here. But this doesn't come to show because there's no politician here or anywhere who would like to say that, by the way, you can only have 70 square meters per person in this country. Nobody wants to touch that kind of regulation. Nobody wants to do that kind of policy. That's a taboo. But that is not an impact. And what is actually happening is that if square meters per capita in Estonia are increasing, that basically cancels all the good things that we can achieve with the climate regulation. You know, even if every single square meter of new building has less emissions, if at the same time the building stock is increasing, what can we really gain? But these are difficult and sensitive politics nobody wants to do. Then the lifestyle issue can be in our hands, just making things transparent and visible, showing that the way you are using your building now is actually better than the standard use. People would work. These kind of things we can do as architects. And then we can also think of this kind of approach, that there's a carbon budget for our lives and our building. This building here, by the way, was calculated by Syria in 2011 or 10, student project at Aalto University. We can think of it this way, that for a sustainable life, you can invest 1 ton of emissions per year. And if your building, your home, eats this budget, it's not possible to live in a sustainable way anymore. But if our building takes only a small slice of it, at least we have enabled the residents' possibility, we have given them an opportunity to lead sustainable life. But if you already burned the budget with the building, there's very little what they can do. And this happened in this house actually in Sweden. The embodied emissions for the Lindell family with the house designed by Gerd Wincourt was just too high. They weren't able to get the emission down to 1 ton, simply because the embodied emissions were already invested, done, and too high. Okay, what else can we read from this method if we want to use it as a tool? Very concrete, tangible advice. If there's a site that requires pile foundation or stabilization, don't build. In Estonia, minimize the energy demand. Energy demand is our domain. We define the energy demand. Then how it's delivered energy is done. Then the building services come in, the technology comes in. But what do you need to keep up the comfortable temperature inside? That is pretty much divided by us. We can work on that. And I've been advocating a method called weighted shape factor to advise us on this, keeping the volume compact and economic. If we make very complicated building envelopes, there's a double impact on carbon footprint. We need more energy to heat it up, and we need more materials to build up the envelope. Then photovoltaics that are important in here in Estonia, but not at all important in Norway. Why? Because photovoltaic output replaces the energy that we get from the grid. And photovoltaic panels come with emissions, done in China with the transportation, so they will come for free. And if we replace really low carbon grid electricity in Norway, it really doesn't pay off to transport them all the way from China. But in Estonia, we are still replacing rather carbon intensive electricity, they pay off. But if we, as architects, place them poorly, so that we don't get the maximum output, we still get the full embodied emissions from the production in China and all the transportation from China, but then we put it in wrong direction, or it is shaded by the building itself, we don't get the output, that the whole rationale behind using photovoltaic panels is compromised. Then if you look at the total emissions, these were per square meter emissions. The effective use of space is important for us, and I will come back to this later, and skip the next one, and go to the question of material choice. There was an interesting debate here about the CLT versus concrete. I believe totally that the results we have in our database are correct, and the embodied emissions are not like God-given things. They are the process of the industry. And now it just happens that the process of Estonian wood industry is not very good. If you burn diesel to dry the timber, results are really good. But also, another finding by Lars Martin and Ransu Helenius is that actually rather small percentage of our wooden buildings are of wood. The share of timber is actually very small. So if you expect that using timber makes a radical reduction, actually the share of timber is rather small. And how could it make a really radical impact if the percentage of timber in timber houses is so small? How could we respond to this? We could design houses that are more of wood, less of gypsum, less of glue, more of timber. And CLT production especially requires a lot of processing. We first split the trunk into small pieces, then we glue it back again on the panels. And then architect comes and says that we need big holes in here because I like big windows. That means a lot of waste. A good recipe for a CLT building would be that you go to the factory, see what is the size that they produce, and use it entirely in your building. And when you have windows, you have full wall windows. and maybe some light frames around it if you put thermal insulation. Then you don't waste the material, you understand the process behind it, and then certain kind of CFD architecture starts to evolve that uses this understanding of how material was created. Okay, so here we come to the next point. What are the expected impacts? Firstly, it's good to know, because this knowledge is different in all these countries. So the weighting of these components is different in Norway, Denmark, Sweden, and Finland. It's good to know what it is in here. Then, of course, we can prioritize the low carbon construction materials as architects, but I believe that the main impact will actually happen here when the industry notices that, wait a minute, we would like to export to Nordic countries, and our numbers look like this. Who will buy our timber if we have such poor values? Will we lose the tendering processes if we come in with this kind of EPD? Probably yes, they will improve the process, and that is exactly what we would like to have. What kind of buildings then we wouldn't like to see? This is a question that the Finnish Ministry of Climate didn't like at all. I was asking, what are the buildings that you would like to cut off with the regulation? They were saying, we don't want to cut anything off, we just want to steer. Of course you cut something off. What is the regulation that doesn't cut something off? What do you need it for? Of course there has to be some compositions that you don't want to see. They are the worst ones. And I think we have to understand exactly what are these. Because we want to steer the development so that we know exactly what we don't want to have anymore. And sorry to say, I've been using this image in many lectures to show what we don't want to have. Here, you know where we are. We are building of concrete, aluminium, steel, and glass. Materials that are all renewable. We have buildings that are almost glass covered, exposing it to rather high heating energy demand. And with all these choices, we are accelerating the climate change that will lead to sea level rise. And we have 3 stories underground ready to suck the water in. So there's both a combination of greenhouse gas mitigation and adaptation neglected in this project. So I would say that we need different solutions. And sorry to criticize, but this is the change we want to drive. And without the change, there's no sustainability. If you remember the commission that was given to Brundtland Committee about sustainability, if the answer was sustainability, what was the question? The question was the global agenda for change. So if there's no change, there's no sustainability. We have something like this developing. Looks very primitive, test phase. No values there yet, but we are using clay and timber renewable materials. Clearly, better numbers in carbon footprinting. Our tool works. We can see that there could be something else instead of that, so big is much. But we want to make that happen. We have to have a demand for these kind of solutions, and then the industry will reply and produce these solutions in different materials. The fantastic feature in here is that with clay that you can find everywhere and doesn't cost almost anything, you can provide fire protection for timber that we need to use in a bigger scale. In expected impacts, we also have to keep in mind, especially in regulation, that if we set the limit value could be also project-based, it could be set in local detailed plan, it could be set in the climate law, but it cuts something off. And we have to be very careful now if the climate law is to be implemented already next year, is that we are not unintentionally cutting something off. These slides are actually a criticism from Finnish construction industry to the first proposal of the limit values in Finland. They noticed that in these 2 buildings, when they were testing different material compositions and district heating and ground source heat pump, the limit value proposed actually was only cutting off the district heating buildings. And this was, of course, not the meaning. We didn't develop a law to cut off the district heating buildings once the city has invested in infrastructure like that. So, when developing this, when working on the limit values, we have to make sure that we are not accidentally cutting something off that we actually wanted to have, but we are cutting off those solutions that are not working towards climate goals. Expected impact. That's difficult to say yet. We don't have the limit values. And in particular, this is difficult because the limit values and the climate law may start developments in industry that are really difficult to quantify. If the brick factory changes the fuel towards low emission fuel, if the timber companies start drying their timber with wood waste instead of diesel, it's very difficult to quantify them, but they are definitely big impacts in the Estonian level. But like I said, there's a good chance that the growth of total building stock volume cancels basically the mitigation. Anyway, it's worth trying. The industry will be more competitive in the export market. The processes will be better in that sense. And it could be maybe the gains exceed the growth that we are seeing in square meters per capita. And really high impact policies are in practice difficult to do. You would need to decide like no underground stories. You need to say limit for square meters per capita. You really cannot do this. You have to tackle the solutions that are within reach. One more section here before I close my presentation. It is interesting question if we can apply these in architecture competition. In Finland, there's some kind of tradition applying carbon footprint limit values in the competition. This was one of the recent ones where half of the jury work was based on quantitative metrics. So 50% of the weighting came from green factor, carbon footprint and energy efficiency, and 50% from architectural quality. And here we see a very fundamental problem, because if we try to wrap together quantitative metrics and architectural quality, the result would be really bad. It was pure luck that this team both had the lowest numbers and really excellent architectural quality. Imagine a situation where the building would be totally awful in architecture, but it would show brilliant numbers in carbon footprint, energy efficiency, and green, or vice versa. How do you do that then? This is something we want to avoid. One solution for that could be that we, these are some observations, we apply a threshold value. So all the competitors who submit an entry have to calculate the emissions and show that we are under the limit, we are fine, and then you are evaluated for architectural quality, but what we don't mix them. The problem with this is that when the competitors do the calculation themselves, they might be quite credible always, because you never know what was the floor area that they were applying and so on. But the good thing is that they inform the process in time. So if you do it in early stage, then you also learn something from the calculation you can improve. And of course, there's also an opportunity of expert assessment afterwards, but the variation in building information modeling, the experts usually make this even more difficult. You would need design teams that have carbon experts. The previous competition was, by the way, done that way. Each team needed to have a carbon footprint expert. So maybe a threshold value could be something to consider. And of course, if there's a national limit value, that might be enough for many cases, but if a city like Tartu wants to be a forerunner, maybe they have more ambitious climate goals, or if the future owner of the building wants to have something special, then this could be an issue. This is my competition entry 14 years back in Helsinki. An area called Fonkasvuo was developed and we participated in the competition. We didn't ask anything about the carbon. I decided that we have a low carbon strategy for this entry. The Finnish method wasn't even published at the time, but I hired one expert to do the calculation with me, and we proposed this kind of strategy. This became a really interesting area. They had written in the local detail plan that all the buildings had to be built with timber frame, and the concrete industry took them into court, saying that you cannot write this in the detail plan. They lost the concrete industry. The detail plan regulation remained, and today, City of Helsinki is applying in all their detailed plans a carbon footprint limit value. So if you want to go and design in Helsinki, you have to know how to calculate the carbon footprint, and you have to be able to show a design that meets the limit value. And yes, we won the competition. Get me employed for 4 years. I will conclude with this. The new perspectives here. We've been working with energy efficiency before, but now the question of materials, efficient use of materials, reuse of materials, tracking, finding low processed materials, natural materials becomes a new issue and a new perspective. How to make these processes more simple, less energy consuming, less transportation, maybe the value of local materials, maybe the value of simple natural materials will be highlighted. It can be reflected with the method if you like. So it's not only for regulatory purposes, but it's gathering more understanding of the climate impacts of our projects. It can be used that way too. Thank you for your attention.
It has been a long day, nevertheless. Are there questions that cannot be left unasked? There is one only.
It is very interesting to see the clay on the future horizons, and I want to ask your opinion on how this material could be implemented as replacement of the traditional Portland cement. Like we had the infrastructure to build these massive concrete panels and all the other machines and all the constructors, companies. Can clay be the material as the cement, the new cement, the green cement?
Now, Siri or Jarek here would be better persons to answer this question, but I think by applying this method, we create an incentive for the industry to have better processes, and we give them a matrix to measure it. Without that, it would be much more difficult to articulate what we want them to do. Now they have a new parameter to follow, and we can compare, we can measure, and we can say that your product is actually not very good, please improve. Without all this framework, it would be very difficult to communicate this need. This is what I find really important. And then what the solutions exactly are, we can also leave that to the industry researchers to innovate. There are many really interesting developments also in Estonia to propose materials that are really low carbon, including things like clay, reed. I know that my colleagues, the experts on environmental friendly construction in Finland, they actually look into Estonia when they want to learn about clay or reed, and they follow with interest all this development with block that is, I can't remember the name after a long day, but there are plenty of interesting developments in Estonia that are actually being followed all the time, and we shouldn't underestimate that knowledge. But maybe Celia wants to comment this concrete development. I won't be able to answer that or this exact process.
Could you repeat the question about concrete?
Yeah, like there is the basic idea is to replace the concrete as the cement part of it with clay. And it mentioned that it's everywhere accessible, but I know that in Estonia clay is not that so, it's more like a Polish clay. And what is the prospect? Is it an utopistic, it's like a fantasia, or can it be something?
Yeah, I don't know about the clay itself, but what I know that really concrete industry should change their production methods, and they do it, and they try to do it. And there is all different. First of all, in Finland they are going to now use more waste products, waste minerals. They try to, like I said, one concrete which is zero emissions or even minus emission, because it takes, okay, maybe I can't call it concrete, but a kind of concrete material, because it goes through the same processes, but just without cement. because the mineralogy composition is exactly right, which and with the help of CO2, the processes and carbonization goes and the same processes, so the material get hard like a concrete. So these are the processes, but yeah, innovation is the next word. So we need many new innovations, and why not the clay?
Aga siis mulle tundub, et täna on olnud väga huvitav päev, inimesi siia jäänud päris palju. Tänan kõiki tulemast, et meil oli põhjust see üles lindistada. Tänan kõiki esinejaid ja järgmise korrani 30.